Hello and welcome back to Mars. I'm Mick and we're playing Stationeers. Now today we're back out in the shed with the adorable AIMeE. That's right, milk it for all it's worth, I called you adorable. Now we've had a bit of a go at looking at other people's scripts and pulling them apart and doing it, but we're not finished yet. So today we're going to have a go at writing a script for ourselves, starting from scratch, and we'll see if we can make it work the way we want it to work. So there's a couple of ways AIMeE works there. It's one, you write the code, you pop it into her head, away she goes. But that's fine if you wanted to stand alone, just let her go and off she goes. But you can also put the chip in a base station here and just control her via the logic transmitter. This will allow us to control her from the base. If we want to issue a new mining location, I don't have to go and find her. I can just do it from the base. And if I want to issue a come back home command, I can do that from the base. I don't have to go out and physically drag her back. So that's the way we're going to be doing ours today. We're going to be creating a base station to control AIMeE. So for that, AIMeE will still need a chip in the head, but we've got a completely blank one here. So just chop in a completely blank chip, and there you go. You're happy. There's nothing in your head. You can quite happily watch some reality TV now and enjoy it. So now that we've settled on building a base station for it, we've got to decide what we actually want from this program. We're obviously going to want to go out and mine stuff and then come back and deposit it off. That much, I think, is pretty much a given. That's the whole point of AIMeE. But there's a few extra things we'd like to do as well. Now she is battery powered, and instead of chasing around and watching a battery, I'd like her to automatically return to base when the battery runs low. And also now that she does get damaged by storms, if there's a storm coming, I'd like to be able to recall her in whenever there's a storm coming. So I want a recall function as well. And I'd also like to, if you do send her out to a spot where there's nothing to mine, that she will know that and just automatically come back to base and shut down and wait for a new mining location to be issued. Now I've seen on the workshop there's lots of different types of scripts out there that do all sorts of wonderful things there. But we still have this movement bug with the pathfinding, and it seems that some people are half and half. Some are in the move to target group, and some people are in the path to target group. So, which one should we use? Well, I say, why can't we just use both? We'll path to target. If she gets stuck on anything, we'll switch her over into a move mode, and that'll hopefully get around it, and she can get back to pathing to target. We'll see if that works. So I think that's about all we need. It's a reasonable list of things. So where do we start? Last time we were using AIMeE, we built a little base station here, which is just the transmitter hooked up to AIMeE, so we could read some of the values that's going on there as they happen. So we know what's happening out in the field. I still want those displays to be on my new version, so I think I'll just use that as a starting point for the new code. We'll need to obviously add a button for a recall command, but that should be about it. So here is my little setup. I've got the transmitter hooked up to our AIMeE Red. I have the IC housing there hooked up to all the panels, pretty much the same as before. I have removed one of the displays so as I could hook up a button because I only have 6 pins. So I've got rid of the display that shows the minables and added a button. Other than that, we should be good. I've got the old code plugged in here, so hit it. D5 now becomes a lever instead of another display, and I've just removed where we set the display. So all it does is it loads from the transmission to the position and copies that straight to the setting. Position straight to the setting, the mode. It also changes the colour of the screen for the mode there, just so it makes it a bit easier to read. And the charge loads from a slot. So the battery is in a slot on the robot, so we've got to use a load slot and then put it on the display. And that's all it is, just goes around in a loop. Switch him on, and we're not getting any errors. Now the transmitter has 3 data imports. It seems to work with only one of them connected, so I've only connected one of them and it seems to go just fine. So don't worry about the other ones at this stage by the looks of it. I don't know why, but let's just roll with it. Now, AIMeE should be hooked up. If we carry around, undignified, but it's working. I can see the X and Y positions moving. So that's all hooked up. Test our code each stage and see how we go. Now before we get too carried away with the code, this one is going to be a bit of a tough one. So we're going to have a bit of a think about it, a bit of a plan out what we're going to do before we get into coding. Right, so here's our plan here. I've just used some comments to try and get an idea of what we've got to do. So now I'm planning on starting from home. So while we're at home, we may as well do things we can do at home. So the first thing I want to do is just make sure the robot's empty. So I'm going to travel to the unload spot, then unload. So that'll be our number one task. And then obviously travel out to the mine site and mine until full, then back to the start. So that's the group of commands we'd want. Now some of the additional things we wanted was to also check for a low battery. Now checking for a low battery, it's going to then have to return to home. So we may as well check for a low battery when we are at home. So when we're at home, we have unloaded, we can immediately check battery. That's just another thing we can do while we're at home. Also, while we're at home, we can also just check the recall button. So that one will allow us to as we're already here, we may as well check while it's out mining, let it mine. When it's come back home, we'll just decide if it wants to actually go out again or whether it wants to stay here. So it will unload, then it'll just see if it needs to go out again. Check those two there. We also wanted to check if it has anything to mine. So to check that, it's first got to go out to the mining location. And before we get it to mine, we're just going to have to check for minables. Rightio. So that one sort of seems to be doing everything we want. Of course, if there is no minables, we're going to have to tell it to come back home again. Now that seems to be tick all the boxes for what we wanted the program to do. So we can probably now start coding. Now looking at this list here, a lot of these ones are going to be pretty simple for us to do. The ones which I think are going to be the hardest are the ones we're getting most ambitious on, and they are the travel to the mining location and the travel to the unload section. So our traversing, because that's where we've got the pathfinding bug, and that's what we're really trying to solve here. So we shall work on our travelling function. Now, to get it to travel anywhere, we first have to give it a set of coordinates. So first up, we're going to need a set of coordinates. Now I've defined a heap of constants here, so these ones will just be points that the program uses. They don't use up any memory because they're just constants. Now I've defined x, y and z coordinates for an unload point and x, y and z points for a mine point. I've also defined the modes for the robot there just to make it a bit easier to read. You don't have to, there is a programmed in table, but I just like to do it this way. Now I've defined a new variable called mode, assigned that to register R1. Now we simply give it a location, which is our unload point, because we're travelling to our unload. Then we change it to mode move. It'll change into mode move until it gets there, then it'll change back to 0. So we've just got to wait until it gets back to 0. So we wait a little bit and then we just load the mode back from the robot and store it into our variable mode. Now if the mode is still equal to move, it's still on the way there, just go back up to our tag, which we put up here, our wait point. So just keep doing that until the mode returns back to 0, then we can carry on. We haven't built any of the other functions here, so the next thing it encounters, it sets a new target out to the mining location and tells it to move there. Once again, it waits. So we should just have a robot moving from one point, then to the other one, and it goes back to the start again. Now I still have my other code sitting at the bottom there. Let's forget about that one for a minute. Rightio. We confirm and export that one. AIMeE starts to move. Should go to our unload point, then immediately turn around, head off a little bit and turn around and come back. And there she goes, coming back again. So she just continually do that backwards and forwards now, because that's all we've programmed it to do. But she's moving. Stage 1 done. Now while she's travelling backwards and forwards, none of our displays are updating because I don't have any commands in there to update the displays. I've got them down the bottom here. They've been taken out of the code, but we want them to do that. Now she will come up, the code will get caught into a loop here, and a code will get caught into another loop down here. Now I can write the code in there to both sections to update the variables, but I don't want to write it twice. I want to write a separate section of code that I can just reuse. So get your programming hats on for this one, because we're just going to write a function to do that. Rightio, now a function is just basically a reusable part of the code. Now we have made branches before in other scripts which have just performed an alternate part of the piece of code and then gone back to the start. This one, however, we want it to do a different bit of code but then come back to where it was called from. And as we've called it from multiple directions there, how will it know where to come back from? To make sure it knows how to come back to where it was called from, instead of just using a jump command, as we do at the end of the program to jump back to the start, we're going to use a JAL. So that actually jumps to the code and then stores the return line number in register RA. So RA is a special register used by the program to control things like this. Okay, so we've got two of them there. So just inside each of those loops, we just called update display, update display. That's a tag we've put down here at the start of the thing that updates the displays. So this will then just, once again, just copies each thing there, updates the display, but when it has to come back, how does it know where to come from? Well, it stored the line number where it came from in register RA. So at the end of this one, we can just jump back to RA. It's changed to blue, so it's recognised that it is a legitimate part of the code. So from there, when we call it from update displays, it jumps down to here and remembers 36 was where it came from. Execute that code. Down there it says jump back to line 36. When I call it again later, JAL, update displays, it'll save line 49 is where it came from. So it'll execute the same code, but then come back to a completely different location, which is 49, where it's meant to be. So that way we can reuse a bit of code from multiple points in a program, and it will remember where it came from. There we go, so she's off, and the displays are working. So she got the locations, we'll change to mode 0, which signals her to come back. Easy, part 1 of it done. Now both of these sections of code here are going to be very similar. We're going to use them to move from one location to the next. So we can also use that as a bit of reusable code. So we're going to go a bit Inception on you here. We're going to change that into a function and reuse that code. And then we're going to call this function from within that function. So here's what our code reduces down to. So we've taken out the waiting code there and moved it down to a function. So we're just reusing the function we've got down here. I'll just call the function travel. So it sets the mode to move, just waits, updates the displays, and goes back to wait, and then jumps back to where it came from. Now, where this gets really tricky is that when we call travel, it stores 33 into RA where it's called from, which is fine, it can jump back to it. But when we call update displays, it'll then overwrite that with 51. Now, if you're not expecting this, this will just really mess with your head. So there is a trick we can use from that. So when we go to travel, first thing we're going to do is push RA onto the stack. So we've got a stack which is just basically a stack of variables, a stack of numbers there. So we're going to push where we came from onto there, so it'll remember RA. Then we go and reuse RA when we update displays. It'll be set wrong now, so we've got to actually get back the RA we want. So we pop RA back, so that gets it back off the stack. So that stores the RA relative to this loop and pulls it back at the end before we jump back. So then this one overwrites it, but it doesn't matter because we've got it saved in the meantime. So that will mess with you. That's a bit of advanced programming there. And I say it will mess with you if you're not very careful when you're using functions. So we've made some changes. Let's check them and make sure they still work. So off we go. The displays are still updating. Gets to a location. She turns around and comes back. That's all well and fine when she's moving from one spot to the other, but what happens if she runs into something? What if she gets stuck? The problem with the move command is that she'll just straight line to wherever she wants to go. The path command will get her around things, but it's pretty buggy at the moment. So if we can just get her to straight line until she gets stuck, and then we can push her over into pathfind and use the pathfind command as sparingly, maybe we can get her around things that way. So first thing up is we're going to have to figure out when she stopped. And there we go, some inconsiderate prick has just built something right in the path of where she wants to go and she's getting stuck. Rightio. So first up, we've got to determine when is she stuck. Now one of the things that comes from the transmitter is her velocity magnitude, which is obviously her velocity. When she's going full speed, she'll chuff along at about 1.2. So we've just got to measure that and find out when that actually drops down low. Now I've defined a new variable here. So we've defined a variable called stuck. We're just going to use that as a counter to count along when it gets stuck on anything. Right, so we've added in 5 new lines of code there. So we're going to load into R0, which is just our reusable variable there, the velocity magnitude. So that's just the velocity of the robot. It normally hooks along at about 1.2, so we're going to say if it's less than 0.2, it's probably stuck or having trouble on something there. So set, if it's less than 0.2, if R0 is less than 0.2, set either true or false back into R0. So we're going to overwrite that because we don't need it anymore. So R0 will be 1 or 0 depending on whether or not it's stuck. So if it's not stuck, 0, you multiply the counter by 0, which will reset it to 0, and then we add 0, which will still be 0. If it is stuck on 1, multiply stuck counter by 1, it'll stay, the counter will stay the same counter, and then we add that onto it. So these two lines will either reset the counter if it's moving, or it'll increment it if it's stuck. And then I'm just going to, just for the time being, I'm going to steal the charge display and just display the counter there. So we're not displaying the charge anymore. I've just put that on there just as a visual indicator for me to let me know that the program's working. Rightio. Then we just keep on going. So it'll just count if it's stuck and won't do anything else. Rightio. We're travelling, it's crashed, we're starting to count up now. It is stuck, we are counting. So we have properly detected that it is moving, that it's stuck. If I reset the code, it should turn around and come back to its home base, and the counter has reset because it's moving again. Right, we're happy with that. Right, so we've added some more code. So now we've determined if or not it's getting stuck. We'll give it a counter of say 20 to get itself unstuck. If it hasn't, we're going to change a mode. So if the counter gets to more than 20, we're going to execute an alternate bit of code. Okay, so we're going to go into our pathfind section of code down here. Now this one is not a function, it will just return back to the wait section up here, so there is no RA called in this one. So we pathfind, so we set the robot mode into pathfinding. We will update the displays just so the displays will update and we know that it has actually gone into pathfinding mode, but then it just sleeps for 10 seconds. The code will just stop and wait for 10 seconds for the pathfinding to do what it does. And as soon as those 10 seconds are up, we're going to pop it back into move mode and try and head back to our target. It should no longer be stuck, so we're going to reset our stuck counter, then go back into this function here and return to our move function. Right, let's see if that works for us. So she moves to the starting point. It should bump into the frame. Boonk. The counter starts. When that reaches 20, she should change to a pathfinding mode. If it wants to cooperate with us, that 2 will turn to a 5. and she'll try and find a way around it. There she goes. She has successfully found a way around it. After 10 seconds, she'll return back to her move function. She's back to her move function. She found her location. Now we're on our return journey. Oh, she missed it this time. Well done. And she's back home. So, all is good. The travelling between point A and B seems to have been solved. Well, mostly solved. We'll see how that goes. So, time to get back to our original bit of code there. Okay, for our next bit of code, we're going to want to unload and mine. So for our unload, we've just saved our mode to unload, and we've gone into an unload wait loop here. So we just called a tag, called it unload wait. We've waited a bit, updated our displays, and we just said if the mode is still equal to unload, if it's still unloading, just wait a bit longer. So we've got that loop in there. The mode is red in the displays one, so we're just reusing that again. So going into that loop until it's finished unloading, and it moves on in the code. It moves to its mining location. Then once again we've just saved, similar to this one there, just saved the mode to mine, created a loop called mine wait, wait a bit, update the displays, then check to see if it's finished mining. Now this one will only mine once. We've only got the mining loop there to wait until it has mined one bit, and then it'll go back to the start. So it won't load until it's full as yet, but that's enough to check our code. Switch it on, off we go. First thing it goes to the unload station. It tries to unload. It's already empty, so off it goes. Now heading out to our mining site. It stopped, now it's going into mining mode. You just go around, find something to mine. And once it's done that, the mode should return to 0. You walked right past a heap of stuff. Its mode should return to 0, at which point it should then return back. So it's gone back into mode 2, and it's on its way back, and it will unload. And stopped, mode 4, unloaded, done, should head back out again. Now we want it to not just mine once, we want it to mine until it's full. So all we have to do is take our mining loop here, it just mines until it is no longer mining and keeps going. So we just then have to tell it to go back to up here and mine again. So we'll create another loop outside of that one to keep mining until it's full. Okay, so I've just put in 2 lines of code. I've created another tag called start mining at the top of the mining code, and I've created another branch. So another loop which goes back up there. So once it's done its mining, the mode will return to 0. So we say if the branch, if it's not equal to full, so if it equals 0, go back to the top, mine a bit more. Wait for it to mine. If it's still not full, go back, mine a bit more. Wait a bit longer. Now once it drops out of here because it's full, it then gets to here. So if it's not equal to full, go back. It is equal to full, so then we go back to the start again and restart our loop. Rightio. Test it. So we're happily mining away. Go turns to mode 0, it's not full, so keep mining a bit more. Here we have a mode 6, so she immediately drops back into a mode 2 to come home, where she should unload. And whoop, into unload. Okay, so we've got her moving properly, we've got her mining properly. Now we've got to set our sights on the other things she's got to do. Probably the next thing on our list here is we want to check the battery and return home if the battery's flat. So for that one we're going to have to create another point, which is our home point, where she goes to when it's going to be where it's safe. So somewhere in the shed, not somewhere out in the weather. because if there's a storm coming, don't want to get her damaged. So we'll need some more points and we'll need another routine to get her home. I have created another function down the bottom of the program. It's called recall. It's the same as the pathing targets that we've got up early in the program, where we just give it a target, XYZ, and tell it to travel. That's all we've done down the bottom as well, except we've given it the home coordinates now. So we've reused our travel command there to get it back. The difference at the end of this one there is we then don't go back to the start of the loop. I've deliberately put this one at the end of the code, so once it's completed this, it just gets to the end of the code. There's nothing more to do. So after it's travelled, we can switch it off, and that's the end of the code. And at the top of the code, to actually call that function, just as soon as we've unloaded, I put in there a branch if less than. So if the charge is less than 30,000 kilowatts, or 30,000 watts, which is 30 kilowatts, we call the recall function. So we've already loaded in the charge. That was part of the update displays command. So now we've got it there to use. So branch, if the charge is less than 30,000, your battery's running flat. 30,000, if your robot's nearby, 30,000 will be enough to do a mining trip. So as long as you've got 30,000, off you go. So I've put in a battery that's less than that, so I should be able to do that. And she should unload and then return to the home position. We're off. You can see the charge is less than 30,000, so she goes there to unload and immediately comes back to a safe location where she switches off. And she's safe. Now it's ready for a new battery. Righto, next on the list. Okay, so next bit on our list is we have to check the recall switch. Now, at the moment I've got a recall button. If you press the button, it is just a momentary thing. So I can't just check it here, because if I push the button while it's in some other part of the code, it's not going to work. So that's not going to work for us. So, but you know, there's always a plan B. Good old plan B. We won't use a button, we'll use a lever. So at the moment it's 0. When we want to recall it, boop. Now it'll stay on that one until it gets home, is ready for it. When it is unloaded, it'll then check it, it'll know that it's on state 1 and it has been recalled. So that should get us out of trouble. Just 2 new lines of code. We've loaded the setting from the lever, stored it in just our temporary variable R0. If it's equal to 1, it has been recalled, so we're just going to use the same function that we used for the battery one and bring her into the shed and shut her down. So now the recall lever is set. When she gets to the unload point, she'll try and unload and then should return to the safe point and shut down. There it is. Inside she comes and shuts down. Rock and roll, we're moving. The last one we've got is actually the check for minables. So if she goes out to an area where there's nothing to mine, she should, I guess we'll just recall her again. She'll come back to the shed and just shut down. Now we've got it there just after she goes to site. She wants to check for minables, but we probably should do it every time we give it, just before we give it a mining one. So I'll move it down to here and we'll put in what we need here. 2 new lines of code. We're just going to load into our temporary variable R0 the minables in vicinity. We're going to branch if that's equal to 0. If R0 equals 0, there's nothing to mine. We're just going to call the same recall script which the batteries and the recall lever call. So if there's nothing to mine, she should just come back to the base and shut down. She won't unload, but that's alright. First thing she'll do when you send her off to a new spot will be to unload what she's already got. Okay, she's running out of things to mine now. She's just up to her last item. 0. She's got nothing to mine. She returned back to mode 0 and then she's on her way back. She should drive straight into the shed and shut down. There we go, all home, safe and sound. And she does have a backpack full of stuff, but as soon as I switch her on next time, she'll just jump over straight to the unloading point and dump all of that. So there we have it. AIMeE is working the way I want you to work. Yes, that's good, isn't it? Most of the time. She occasionally still weirds out. If she does weird out, you can just lobotomise her, just pop out the chip and reinsert it into her head, and she generally goes back to doing the right thing. As always, that's not the only way of doing things. Now, I've chosen to hard code the mining location in there. If you decide to suddenly put up a heap of them and have them all going out there, I'll have to recode every single one of them for a unique location if I don't want them all in the same spot. An alternative to this is if you don't want these chips here, or don't want the displays here, you can replace them with memory chips. You could code your mining location into the memory chips, and then all of them could just run the same code. So these displays are just doing whatever information we can get off here. So if it does get lost and doesn't come back, I can still get its position straight from the device configuration. Easy enough. But that's up to you. I'll leave that to you. My brain's burnt from doing that much there. So until next time, happy building. See ya. Holy crap, 526. Yup. Now the storms do damage your AIMeEs. You can see this one here I left out in the storm and it has been damaged just to test if it does get damaged. I may have kind of shot her as well, but the storm did damage too.